So now let's look at an example involving Venn diagrams. So let's say I want you to draw the Venn diagrams for the following two sets. And those two sets are going to be A intersect B, union B intersect C, and the set A intersect C. So here I have three sets that I'm considering, so that means my Venn diagram will have three circles. So let's draw A intersect B. I'll make that one blue. A intersect B. It's what's in common to A and B. So there's A intersect B. And now so that's what I've done in blue. Now let's shade in B intersect C. Now that's going to be red. And here, what am I doing between them? I have a union, which means my final result for this Venn diagram will be anything that was shaded in at all. So the Venn diagram for this set would look like this. So this is A intersect B, union B intersect C. So on the flip hand, let's draw the diagram for A intersect C. A intersect C will be this region right here. So there are my Venn diagrams. So now I can ask, how are these sets related? That's what I want to know. Is one a subset of the other? Are they equal? Is neither a subset of the other? So how are these sets related? Well, I can tell that these sets are not equal because they don't contain the same shaded region. And then if I look at the one on the left, it has some region that's missing over here. So the first one isn't a subset of the second one. And if you look at the second one, this region that's over here on the left, it's missing from this one over here. So they both contain regions that aren't in the other. And so what I can say is that neither of these sets is a subset of the other. So to prove that, so in this case, we're trying to show that they're not subsets of each other, so we need to find a counterexample. So I'm going to draw my box U. When you give your counterexample, you need to give the universal set as well. Now, I need to make sure to include elements in the regions where they didn't overlap, that were different in each. So I need to make sure to include elements in where these two arrows are located. So let's look. I'm going to do this set. Let's go 1. I need something in this one here, so I'll put 2 there. And I need something here, 3. Then I'll just put in some more numbers, 4, 5, and 6. So my universal set are the numbers 1, 2, 3, 4, 5, and 6. My set A consists of the numbers 1, 2, and 3. My set B consists of 2 and 4. And my set C consists of 3 and 5. So now I'm going to compute my sets that I was looking at before. A intersect B. The only thing in common is 2. and then B intersects C. B and C don't have anything in common, so that's the empty set. So then A intersect B, union B intersects C. If I take the union of these two sets, it would just be the set containing 2. And then if I look at A intersects C, the only thing in common is the set 3. And we know that 2 is not a subset of 3, and 3 is also not a subset of 2. And so this tells us that A intersect B, union B intersects C. This is not a subset of A intersects C, and vice versa. A intersects C is not a subset of A intersect B, union B intersects C. So if you're saying that neither is a subset of the other, you need to come up with a counterexample to show that.